Welcome guys to another video. This video is I'm gonna make it or request a comment about chamfering when it comes to the grooves, if you can chamfer outside of 45 degree. So what I'm gonna do is I'm gonna insert a line. All right, we're gonna go turning T groove, and so this is going to be our common unit, and we're going with the out grooving and the options. So I'm going to show you two of the options. So number one, okay, then it's asking me number of grooves, so we're going to do one groove. Pitch of the groove is 0 because it's only one. Size of the groove, let's call it 400,000. Finish of the groove, so 3,000. So last pass is gonna only take 3,000. This is my tool. The pattern, we're gonna use standard. Depth of cut, T, that's gonna be, that doesn't matter for this video. We're just gonna talk about options. So now, so we have in our figure, corners, starting point X, finish point Z, starting point Z, finish point X, and finish point Z. Then you have a final corner and angle. So when it comes to chamfering, and like I said, so let's call that we have 1 inch part. So our starting point is 1 inch. We are starting point Z at 1 inch. Let's say our final point X is going to be 800,000, right? So it's going to be 100,000 depth per side, and final point Z is going to be 1 inch. So technically what we're doing is, we have 1 inch part, okay? And then our starting point is 1 inch, right? So right here, our starting point Z is 1 inch. So let's say this is going to be 1 inch. So the groove is coming here. We're going to 800,000 deep. Our final point Z is going to be the same point. So that means we're starting from starting point Z and final point Z is going to be here and here. The width of the groove is telling us how wide it's going to be. So we're telling us the width of the groove is going to 0.400, so 400,000. So that's the thing is, remember, starting point Z, finishing point Z. So this will always give us a nice square groove once we're going to get into angles. So number one angle, so number one pattern, right? When you look at your groove, the actually width of the groove is going to be here, not this little section. So for example, if I need 400,000 wide groove, it can be here. So if you're going to tell your machine to make 400,000 groove, it's not going to make this section 400. It's going to make this section 400. So whatever this is going to be, this is going to be much smaller. And if you go to that question mark, you could see what calculates. So as you see number 0, this is the one we talked about that we're gonna use for cutoff, right? Ours, if this is our 0, the starting point and finishing point on a Z is always the end of the groove. As with number 1 and number 2, this is your starting point, and this is your final point. But as you see, the total width of the groove is the top, it's not the bottom. So for example, if you have, and let me just say that, for example, let's do program, toolpath, and part. Let's do this point 2. So as you see, you have a normal groove, right? And for example, you just want to throw in the chamfer over here, it's not a problem. You just go to starting corner. Okay, I'm gonna insert 30,000. if I'm going to back to the toolpath, okay, and now you see we've added that 30,000 corner, and the groove didn't actually change shape, right? But let's say the question was, what if I want a different corner than 45,000, right? Because that starting corner is always 45 angle, okay? So the way we do it, okay, I'm gonna erase this. So let's say my starting point is gonna be 1 inch. My starting point Z is gonna be 1 inch, okay? My final point X, let's say it's gonna be 800, but we don't know what the Z is going to be because our angle is gonna be here, okay? So once again, you press angle, let's say you want 30 degrees, okay? And then you press the soft key on the right side, you press the calculate, and it's gonna calculate the number for you. So now if we're gonna go back to our toolpath, part, and as you see, this is that 30-degree angle. So the starting point and everything changed, but now the groove is 400 here, but it's very, very small here. So what I'm trying to get is, let's say if you get a blueprint and the customer wants the groove to be actually 0.400, and now our groove is very, very small, as you see as over here. So what you would have to do, okay, is go here, and you could see that the groove got smaller by 173,002 tenths and one, I think it's a microtenth. You'll have to add that number twice and then add it to the width of the groove. So then what would happen, so and like I said, this is 30 degrees, so let's make it, and I'll show you what I'm talking about, much easier. We're just gonna use a regular 45 degree because it's easy to calculate. Okay, so our groove is 400,000. We're starting point 1 inch on X, 1 inch on a Z. My final point is 800, right? So 100 per side. And then my final point Z, okay, my final point Z is gonna be calculated. So here, calculate. Okay, and it's showing us that we are having 100,000. 100,000 goes from 1 inch to technically 1 inch and 100. So it's a 100,000 chamfer, right? So toolpath, part. Okay, so 0.3. Make a little bit even on 1. Okay, so technically, as you see, now this is technically 200,000 here, because from here to here we know it's 100,000. So from here it's 100,000, right? So once you add them together, this is 200, this is 400. But we need this groove to be, let's say, 400 and not this one. So all you gotta do is take that difference. So 100 times 2 is gonna be 200, okay? And I'm gonna make this as 0.600, okay? And as you see, now this is 400 and this is 600. But as you see, it got shifted to the, further away. So as long, if it depends if you have this section provided, let's say on your blueprint or this one, but this hasn't changed. Only the distance got pushed, but it does give you this distance. Like I said, it's 400, and now this is 600, right? So that's the whole concept of it, is that if you're trying to pretty much calculate the angles, and like I said, 45 is very simple, or you can go, let's say 40, and we have our starting point Z. And remember, it's like if for example, if you're trying to compensate, because we have 100,000 here and everything got shifted, then sometimes you might have to shift the Z too. So this whole thing, what I'm talking about, it is if you have a print, okay, and you have an angle groove, what is the print telling you? You need to start here, or do you need to start here? Sometimes they'll give you end this point or this point of the groove, right? Is this dimension you're supposed to hold, or this dimension you're supposed to hold? So all these things do kind of play a role, but they're pretty easy to calculate. That as long as you have, let's say, this point and width of the groove and some sort of a depth, then once you press the angle, you can question mark any of this. You can question mark this. Go here. Let me see. Go here. Find that question mark. Press it, and then do calculate, and it'll give you the dimension. So you can technically question everything as long as you have them. The only thing is, like I said, you have to just remember that this is the actual point of the groove, and this is gonna be like a byproduct, or this will change. This dimension will change to the angle you'll give it compared to the top one. Okay. Now, what if you only have, let's say, 30 taper, and then there's a remaining groove, right? Because as you see, this will give you always this one. So then you have to make another unit, unfortunately. So let's do this. So we have 0.400, okay? Everything is changed here. We're gonna start 1 inch, right? 1 inch. We have 0.800 depth. Let's do that 45 degrees here. Okay, I'm gonna question mark this one. It's gonna come out the same. We'll calculate. Okay, program, toolpath, part. Let's do scale 0.2. Okay, so we have a regular groove. So let's say that we wanted that 400 groove and 200 on the bottom, right? If you needed 600, if you need 400 on the bottom, right, then we need to make this additional 100 here and here. So then the top would be 600 and 400 on the bottom. But we know that from this point, this is 1 inch, okay? This is 1 inch and 100. So we add 200. So this is 1 inch and 300, and this is 1 inch and 400, right? So we adding. So we know this is 100. From here to here, this is 200, and from here it's 100 again. So now if I need additional groove, just a regular one, then I would insert another unit. I know, guys, this is kind of, it is what it is, right? So I'll press 1, number of grooves 0. Oh, 0. Number of grooves is gonna be, 1, 0 pitch. We need that 200 wide. Everything's gonna be the same. 100, 200, 200. Let's call it 10,000 feet or 40,000. Doesn't matter. This is just for purpose. So now the starting point X. So since we finished at 800, I would start with 800. Final point Z. That's gonna be that 1.1. Final point X, let's say we need to go to 600, so a little bit deeper. I'm gonna repeat this 1.1, okay, and then we're gonna have this groove. So 1 inch, 100 to 8. Now we have, so this section is 200, and then we add another 100, so the total is 400 here, and total is 200 here. This is 100 depth, so from 1 inch to 800, from 800 to 600. So we have 100, 100, or so that's 200 or 400,000 per side, right? From 1 inch to 600 if you measure on a mic. So this is how you kind of deal with these chamfers on what do you call it, on angles. If I'll do like a different angle, and you see what's going to happen with this one. Just for a purpose. So we'll make a bigger pitch. We're gonna make this 30 degrees, right? I'm gonna question mark this one. Let's calculate. Okay, and you're gonna see what happens with this one. See, now this changed angle to 300. So if you don't know what this section is, how wide it is, or you don't know what this is, all you have to go is to take width of the groove, okay, which is 400, and we're starting at 1 inch, we're finishing at 1 inch and 173 and all these numbers. Take this number times 2, okay, and then subtract it from 400, and that's going to give you the final number. So this will be, let's say, 100, okay, and you subtract, so 100 times 100 plus 100, that's 200, minus 400, you know, that bottom will be 200. But I'm not that good of a calculator. I don't have a calculator in my head, so I actually have to use calculator for the purpose of the video. So I hope that I clarified this well enough. Now, let's talk about one more option, actually, pattern. If you just want a simple one-sided chamfer, like for example this one. As you see, this one is super simple. You give the actually grooving starting and finish over here, and it throws a chamfer, and this will actually give you the whole groove, not just one side, right? So you have this one and this one. So let's go with number 4. So I'm gonna erase this. So we're gonna pick number 4. Okay, it's this one. We have 1 groove, 0 pitch, okay, 100 depth. For example, my starting point is 1 inch, final point Z 1 inch, right? So see, as we don't even have final point Z. Your starting point Z is only 1 because this groove will only go down. You don't have option to go sideways, but it allows you to throw in a chamfer. So chamfer, we have starting point X and final point X, right? So that means it allows you to go this way only. We only have 1 Z, there's starting point Z, there's no final Z, right? So that means you cannot shift this at any point, sorry. So final starting point X, final point X, right? Our Z, it's only 1. So that means you can only go down. It does not allow you to go starting point Z and shift your Z position, right? Only have starting point Z, which is here. And then it will allow you to throw in a chamfer of 40,000. And so let's say we're going from 1 inch to 0.800, 40,000 chamfer, and then 1 inch on a Z, okay? Right here. This is one of the, if you do in a single side, this is one of the easiest options to use, 0.2, as you see. So this is 1 inch here, 1 inch top, 800 bottom, 40,000 chamfer, very simple. If you need a chamfer on the other side, you just use the another option. All right guys, so this is the grooving patterns, how you calculate it. I hope I didn't mess it up too much, that you actually get the whole point. And what do you call it? So the best option for that, like I said, it's pattern 3. And like I said, so just remember, this is your starting and final, beginning. This is end of the groove, the beginning of this groove technically, but these, if you can go straight or you can do taper, but if you do taper with different angles, you don't have an option to do it straight, so you need to throw in another grooving pattern, grooving unit. This is just for your right side, this is for your left side. This is that simple when you only have one option on your Z, right? So but you can throw in any 45-degree chamfer at it, and this will give you same thing, but except for the chamfer on the left. But as you see, if you start 1 inch, right, so both of them have same starting point. So 1 inch, let's say on a Z, same thing as you give it a 1 inch and 1 inch. The width of the groove is gonna define this side, and then you can throw any chamfer. All right, so I think we covered technically most of them, because I know in my previous video we covered this one, but I didn't technically cover when it comes to changing angles on the tapers and this one, and this one you can do that comfortably. On this one, technically yes, but this is more as a cutoff, so it only allows you to go in once. There's no rougher finish. And this one is technically only for 45-degree chamfers, but it's the easiest one to program. I actually haven't used them much more often, but now, like I said, when I play with those, it seems that sometimes if you have a single-sided chamfers, I think this will be a really good to go, especially if you have a groove that's got a one chamfer smaller or bigger on each side. Then you can combine them together and pretty much get the job done the same way. Alright guys, thank you for watching, and to the next time.